Welcome to Topic 5, Unit 3, Parametric Equations. Recall from the investigation that parametric equations are when we define x and y are functions of another parameter. Typically, we make that parameter time. So we can see here that we have defined x as a function of time and y as a function of time, and we call these parametric equations. Example 1, graph the curve defined by the parametric equations x equals 3t squared, y equals 2t, and t is between negative 2 and 2. Then find its rectangular equation. So I'm going to make a table that has t as its input and x and y as its outputs. And then I'm going to put in numbers between negative 2 and 2. So I'll do negative 2, negative 1, 0, 1, and 2. So if I plug in a negative 2 into x, I wind up with a positive 12. If I plug negative 1 into x, I wind up with positive 3. A 0 gives me a 0, 1 gives me 3, and 2 gives me 12. And if I plug in a negative 2 into y, I get negative 4, then negative 2, 0, 2, and 4. So now I'm going to go over to my graph and I'm going to draw my y-axis, my x-axis, and I'm going to plot my ordered pairs x and y. So the first point I'm going to plot is at 12, negative 4. So here I am at 12, negative 4. Then I have a point at 3, negative 2. I have a point at 0, 0. I have a point at 3, positive 2, and 12, positive 4. And then I want to join these with a smooth curve, keeping in mind the order that I drew the points. So I started from down here and I started moving in a clockwise direction until I got to my last point. So now they want us to find its rectangular equation. So what I can do is I can solve y equals 2t for t. So that means then that t is equal to y over 2. I can substitute that in for t into the x equation, and I get that x is equal to 3 times 2 squared, or x is equal to 3 times y squared over 4. And as you can see, this is actually the equation of a parabola that's on its side, which is what we graphed. Example 2, it says graph the curve defined by the parametric equations, the same ones that we did in example 1, but they want us to do this on a graphing utility. So I've pulled up my HP Prime calculator, and the first thing we need to do is select parametric from the app menu. So if I scroll down, parametric is down here. And then I'm going to enter the equations into y equals. And I am going to say that x is equal to 3t squared, okay? And y is equal to 2t, okay? And then the next thing I want to do is adjust my viewing window. So let's go to Shift, Plot for the setup menu. And I want to tell it that my t range is going to go from negative 2 to 2. And then I know that from the graph that I've already done that I need to be able to have an x min of 0 and an x max of 12. And I need to have a y min of at least negative 4. I'll just make it negative 5. And a y max of 5. And now I will go ahead and I will hit the plot. And there you can see what we graphed before, which is that parabola on its side. And if we were to touch the graph in various places, you can see that down here t is equal to negative 1.67, t is negative 1.29, t is negative 0.62. Up here, t is equal to a positive number. So you're able to tell by just looking at the points which direction the graph was drawn. Example 3. Find the rectangular equation of the curve whose parametric equations are x equals 2 cosine t, and I somehow lost the y value. Y is supposed to be equal to 2 sine of t for t between negative infinity and infinity. So I'm just going to start with some numbers and see what happens. So I'm going to make my table t, x, and y, and because I have cosine and sine, I'm just going to start at 0. I'm going to do pi over 2, pi, 3 pi over 2, and 2 pi as a starting point, as representative of negative infinity to infinity, and then I'll go from there. So if I plug in a 0 into x, 2 times the cosine of 0 is 2. If I plug in pi over 2, I get 0. If I plug in pi, I get negative 2. If I plug in 3 pi over 2, I get 0. And when I get back to 2 pi, I reach 2 again. And then if I plug these values in for y, 2 times the sine of 0 is 0. This would be 2, this would be 0, this would be negative 2, and this would be 0. So if I graph these points, I would first graph the point at 2, 0, then 0, 2, then negative 2, 0, 0, negative 2, and then I am back at 2 again. So these are points that make a circle, and the points are going to go in the counterclockwise direction, and they're just going to keep going around and around the circle for t equals negative infinity to infinity. They also asked us to write the rectangular equation. Now I'm not able to isolate t in a manner that would be helpful in these equations. So instead, I'm going to use an identity. I know that sine squared t plus cosine squared t is equal to 1. So I'm going to say then that the cosine of t is equal to x over 2, and the sine of t is equal to y over 2, and I'm going to plug them in to this equation. Now I'm going to simplify, and I get y squared over 4 plus x squared over 4 is equal to 1. And if I multiply both sides by 4, I get x squared plus y squared is equal to 4, which is the equation of a circle centered at the origin with a radius of 2. And that's what I've drawn. But when I look at the rectangular equation, I have no sense of the direction that the points were plotted. Example 4, find rectangular equations for the following curves defined by the following parametric equations. Then we're going to graph each curve. Well, as you can see, I have the exact same equations that I had in example 3. And so this gives me the same equation. X squared plus y squared is equal to 4. So we would expect that if we graph these parametric equations, I'm going to get a circle again. But let's see what happens now that we have changed the interval for t. So I'm going to plug in a 0 for t, a pi over 2, and a pi, and then I'm going to make a column for x and a column for y. And if I plug in a 0 for x, I get 2, then I get 0, and negative 2, and for y I get 0, 2, and 0. So I will plot these ordered pairs, 2, 0, 0, 2, and negative 2, 0, and then I have to stop. So based on the parametric equations, I'm just graphing a half circle, yet my rectangular equation implies that I would be graphing a whole circle. And then we'll look at part B. This time the parametric equations are defined slightly differently. I can say that the sine of t is equal to x over negative 2, and the cosine of t is equal to y over negative 2. I can plug them into the Pythagorean identity, and I'm going to get x over negative 2 squared plus y over negative 2 squared is equal to 1. Well, when you square negative numbers, they become positive, so I wind up with x squared over 4 plus y squared over 4 is equal to 1, or x squared plus y squared is equal to 4. Again, I am getting this equation of a circle, but let's see what happens when I make my table. So I've got t, x, and y. I'm going to plug in 0, pi over 2, and pi. But this time, when I plug in a 0 into x, I'm actually going to get 0. And if I plug a 0 into y, I'm going to get negative 2. If I plug in a pi over 2 in for x, I am going to get -2, and if I plug pi over 2 in for y, I'm going to get 0. And then if I plug pi in for x, I'm going to get 0, and for y, I'm going to get +2. So I'm going to plot the point 0, -2, -2, 0, 0, 2, and this time I am getting half of a circle that I am drawing in a clockwise order. So hopefully you see that in some ways parametric equations are richer than rectangular equations because they give us a little more information about how the curve is being drawn. Example 5, Tanya, who is a long distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves your house, you leave in your Honda and follow the same route. If your average speed is 40 miles per hour, how long will it be before you catch up with Tanya? So here we have two distance equations. We have Tanya, and we'll let x1 represent her distance, and then we have our Honda, and we'll say that that's distance is x2. Now remember that rate times time is equal to distance, so for Tanya, who has a rate of 8 miles per hour, her distance is going to be 8t. Now the Honda drives at 40 miles per hour, but remember that it starts driving 2 hours after Tanya starts. So I need to multiply this by t minus 2. So that way when t is equal to 2 hours, the Honda's position is going to be at 0. So in order for us to figure out when they will be caught up, I need to set x1 equal to x2. So I have 8t is equal to 40 times t minus 2. 8t is equal to 40t minus 80. I'm going to get that 80 is equal to 32t, which means that t is equal to 2.5 and time is being measured in hours. So to answer the question, the Honda catches up 2.5 hours after Tanya leaves the house. That's all for now. Thanks for watching.